Okay, yeah, thanks everyone for being here. Right, so my name is Dong Song. I'm a professor in computer science at UC Berkeley, and also the co-director of a new campus-wide center called Center for Responsible Decentralized Intelligence. I'll actually talk about that in a second. And the founder at Oasis Labs. Okay, so yes, so I'll talk about zkcollective initiatives. So first I wanted to quickly talk about our ZKP hackathon that we just announced on March 1st. It's starting on March 1st. It's both in virtual and in person at UC Berkeley. It runs for 2 months. And we welcome people to join. And you can get more information if you scan that QR code. So this hackathon, we actually have up to, thanks to the sponsors, we have up to 200K plus in prizes. And thanks for Gnosis Builder also as a sponsor. And so we have great judges. And it's hosted by, as I mentioned, Berkeley RDI, which is a new center on blockchain Web3 with the mission to advance the science and technology of Web3, decentralization, and decentralized intelligence. And it's cross-campus, multidisciplinary, across computer science, School of Engineering, law school, and business school. And for information about RDI, we do lots of different interdisciplinary research. You can go visit rdi.berkeley.edu. So the ZK Bridge project that I mentioned is part of the, came out of RDI as well. And also you'll hear the specular talk a little bit later in the afternoon, a new optimistic roll-up that also came out of RDI. And also, we have been leading a few MOOCs in collaboration with other institutions. And these may be helpful for people in the audience here as well. So we have the world's first DeFi MOOC. You can go to defi-learning.org. We also did the entrepreneurship in Web3 MOOC last year as well. And right now we are doing the ZKP MOOC. You can go to zk-learning.org to learn more about the ZKP technologies. And currently we have about 3,500 enrolled all over the world, so that's been really exciting. And also with RDI, we also have a Berkeley Blockchain Accelerator that has incubated over 85 teams and that has raised follow-on funding for over $450 million. So for people here who are interested in building new ventures, please check out this as well. So it's a great way to help incubate your project. And interesting, so the format got messed up a little bit, but it's okay. Okay, so then, so for the hackathon, we actually, so I wanted to share a little bit about the hackathon, which actually is also part of the initiative from the ZK Collective as well. And so the hackathon tracks actually have been designed especially with the two actually main goals. The first one is we wanted to show that every developer today now can learn to use ZKP technology for building apps. So that's a ZK application track. And then for the other tracks, essentially, we actually want to take a community effort approach where we wanted to show that with decentralized collaboration, it can effectively bring the community together to build the key technologies and public goods in zero-knowledge proofs. So this includes actually 3 tracks for the hackathon: ZK Bridge, ZK Circuits, have the community come together to write optimized circuits, and ZK Benchmark track, where we bring community together to build benchmark frameworks for the different ZK frameworks. So, and as I mentioned on the panel earlier, also is that we really want to bring the community together to build public good. And here I want to just talk about first with the ZK Bridge project specifically. So for the earlier panel, we talked about building this trustless bridge. But for people who don't have much background in that, so I'm going to quickly talk about our work in ZK Bridge, how essentially we use zero-knowledge proofs or succinct proofs to build these truly trustless and permissionless bridges. So first, So everyone here knows about cross-chain bridges. So in the future, we think the future will be multi-chain universe, and the bridge is essentially the most critical foundation for this multi-chain interoperability. It provides generic and efficient communication across blockchains. And for these bridges, we want to have a number of desired properties. It should be extensible and general so that it can support different types of applications. It should be efficient. And also, we wanted to really be secure with trust minimization. And right. So yeah. So anyway, so the bridge helps syncing the state from one chain to the other. Right. For example, here from the source chain to the destination chain. However, so far, most bridges actually, because they wanted to be efficient, oftentimes they actually suffer from the trust model side. So either they use a sidechain, or they use a committee, or they use oracles. So with all these approaches, they essentially rely on trust to these intermediaries. And but however, so essentially all these different approaches, they rely on different trust models. But ultimately, you all need to trust some like small communities. And what we have seen in practice is that we have seen these bridges have lost a huge amount of money under these reward attacks. And actually, a number of them is because actually these communities really have been compromised. So the question is, can we actually build practical bridges without any of these additional trusts, without actually having to rely on trust on intermediaries? So that's what motivated us to develop this new approach called zk bridge. Essentially here, using zero-knowledge proofs, in particular succinct proofs, we replace these honesty assumptions on these trust intermediaries with essentially cryptographic assurance. And also, our goal is to still make this efficient and practical so that we can really deploy this in the real world. So this is how the zk bridge solution actually works. As essentially with the zk bridge, as I mentioned, we use succinct proofs. So first of all, we have this block header relayer. And here, really anyone, it's truly permissionless, so anyone can be a relayer that relays block header from the sender chain to the receiver chain. And as it relays the block header, essentially it generates a proof that the block header is correct. And this proof, essentially, as you can think of it as it's doing like client verification. And the specific like client verification depends on the different chains, consensus, protocols, and so on. And on the receiver chain, we can deploy what we call updated contracts. And this updated contract essentially will verify the proofs that's been submitted by the block header relayers. And then in this way, then as long as the updated contract is correct, then essentially we can ensure that this bridge is secure without having to rely on any trust. Like here, we don't need to trust, for example, the block header relayer. And then on top, we can build different applications. We have these application contracts, which can get block header information of the sender chain through this updated contract. So this is how we can develop these fully extensible applications on top of the zk bridge. So with the zk bridge, we have a number of different advantages. Already, as I mentioned, it's minimized trust, so that we don't need to trust any intermediaries. And we provide efficient online verification through state-of-the-art, new scalable, efficient zk-SNARK technologies. And it's truly permissionless and decentralized. So as I mentioned, anyone can be a relayer to relay the block headers. It's extensible and universal because the underlying zk bridge base layer provides essentially the core parts of the bridge functionality, which is to relay the block headers. And this allows developers on their own to develop different applications on top of the bridge. So for ZK Bridge to work in practice, the key challenges is that, as we all know, like ZK can be, the proof generation in particular can be expensive, and a number of existing blockchains are not designed to be ZK friendly. So for example, some of these signature schemes that are used are expensive to express as arithmetic circuits, so they are not very ZK friendly. And oftentimes, for example, for Tendermint or for some of these other examples, like you need, for the light client verification, so you actually need to verify a large number of these signature verifications. And so generating these zero-knowledge proofs can be very expensive. So what we have done is that we have developed various new ZK technologies, so including what we call Virgo, which is a new distributed version of Virgo, a strong scheme that we developed earlier that's much more efficient for on the proof generation side. And with this distributed Virgo, we can get significantly reduce the time it takes to generate the proofs by essentially doing parallelization. And also, on top of this, because the Virgo proof size is still a little large, to enable efficient on-chain verification, we need to reduce the proof size. And here, we essentially do that by proof recursion. And so essentially, we bring together and get the best of both worlds through the proof recursion so that we have constant size proofs, but still very efficient prover time. And with this, essentially, with the Virgo, we generate, or we enable efficient practical proof generation for these really large circuits so that so we can actually make ZK Bridge solution practical. And again, to summarize, so for the ZK Bridge, essentially we focus on the base layer. We provide this base layer where, again, any block header relayer can relay the block header with the generated succinct proofs attached, which can be verified on chain, on the receiver chain, by this updater contract. And then the updater contract provides an API for applications essentially to learn about the latest state of the other blockchains. So that's why I mentioned earlier too, like for this bridge, essentially we really have this decomposed view where we focus on building the general base layer and enable applications, a developer to build different applications on top. So with this, then ZK Bridge solution provides great extensibility, enabling different types of applications, including message passing, cross-chain asset transfer and swap, NFT operations, and many more. So this is a quick summary for the ZK Bridge approach that makes a trustless bridge practical. So, and for more information, you can go to zkbridge.org. So however, ZK Bridge is only just the first step. So we have been building up a community efforts that we call ZK Collective to really help bring this more into practice, to help build a secure universal foundation for multi-chain interoperability. So if you're interested in joining ZK Collective, you can scan the QR code here and fill in the form. So let me talk a little bit more about the goals of the ZK Collective. So the ZK Collective so overall, we have various goals in the ZK area. But for ZK Bridge, the goals for ZK Collective is really, as I mentioned, to help build a secure universal foundation for multi-chain interoperability. And for security, I already talked about trust and minimize with the zero-knowledge proofs. And also another important aspect that we hope to, together with the community and also actually Martin and from Gnosis and so on have also been making new proposals in this area. We call it defense in depth. So the question is, even with the ZK Bridge, theoretically speaking, it really offers the strongest security, but the implementation, like the zk circuit and so on, could have bugs and so on. So in general, we want to achieve defense in depth such that we can have proof diversity. There are different approaches to generate the proofs. And also there are multiple implementations. There are different implementations for the zk circuits and so on. And also we can combine with other approaches such as optimistic bridge solutions as well. And altogether, we hope to actually build, essentially to get the best of all these different approaches and to enable defense in depth such that it can really provide the strongest security in practice. So that's the security. And at top efficiency, we want to make the approach really efficient, in particular using more advanced zk technologies. And we want to achieve really great user experience, for example, low latency, low fees, close to zero fees, and the extensibility that I mentioned as and make it universal to connect to different chains. And also, ideally, it's self-sustainable. And really, with the zk collective, we have the following principles that we want to promote and to build open source and open ecosystem, and really building public good. And also enable this collaborative effort to bring the community together to collaborate on this. And for zk collective, people ask how they can join. It's really open to anyone, so anyone can join. We already have a large number of projects, entities, and individuals that have joined. So really, across the whole ecosystem, I think everyone can contribute to this zk collective. And the zk collective, the goal is to carry out various activities in the space, including research, education, and also building like reference implementations, and including standardization that we talked about earlier on the panel as well. And we want to help build new proposals to improve zk friendliness of different chains and various tooling development as well. And also with the goal, in the end, to really help build a self-sustainable ecosystem. So this brings us back to the ZKP hackathon. As I mentioned, actually, one of the tracks is on ZK Bridge. So this hackathon, the ethos of the hackathon, and also for this track, is really what I mentioned earlier, is to bring the community together to build public good. And so ZK Bridge, if you actually look at the approach, the solution itself, it's actually highly decomposable and parallelizable. So it's actually great for decentralized collaboration. So with this track, the goal is that we want to enable decentralized collaboration to bring the community together to build ZK Bridge as public good. And also we want to get diverse implementations to enable this defense in depth that I mentioned earlier. And you can go to the website here to see more details about the ZKP hackathon, and in particular, the ZK Bridge track. And within the track, we actually have several different categories for participants to contribute, including circuits, smart contracts, message relay services, building applications on the ZK Bridge, and also defense in depth, as I mentioned, where people can propose different solutions for defense in depth. And also, again, it's really designed in a way we, in particular, have decomposed the tasks into very fine-grained tasks so that it's very easy for participants to contribute, even when they just have a few days of work that they can contribute. They can already make meaningful contributions. So again, with ZK Collective, the goal is to advance ZKP technologies and also to enable, to bring community together to build this public good with open source and open ecosystem. I wanted to briefly mention another initiative that ZK Collective is carrying out with this ethos as well, is to build, to bring the community together to build a benchmarking framework for different ZK frameworks called ZK, you can go to zk-bench.org. And so this is also one track in the ZKP the hackathon as well. So again, we have broken down the tasks into very fine-grained level so that each participant, even if they just have a few days of work or 1 or 2 weeks of work that they can contribute, we hope that people can contribute and then together with the community, we can build this zk benchmark overall solution. And to make this possible, we have developed this zk harness framework that essentially provides standardization for integrating different zk frameworks into this overall platform, and also have standardization for input-output specification, workload specification, and so on, so that people can plug in workloads, and then the system will actually collect the logs, analyze the logs, and even plot the results on the web front end. So with that, the call to action is that we hope, again, here is to bring everyone together to build public goods. And so we hope that people, you can join the collective by, again, scanning the QR code here and help spread the word and help contribute to the different activities and so on. And again, please help spread the word for the ZKP hackathon. And right now it's actually the sign-up phase, and people can also team up together as well. So for more information, you can go to the website here to learn more.